Hey, Steve, everybody.
So, Jason, we've known each other for 14 years, so 2 as a rep and 12 with the company, right? And I can remember the day I met you when I was being vetted for the company, and came in and sat down and talked to you, and you actually gave me thumbs up, which is kind of funny. But a lot of the people here who are online tonight have also had the golden opportunity to meet you and get to know you, and you've helped them out with a lot of things. So I have to ask you, when did you start with NTI, and why the heck did you start with NTI?
Good questions. I started initially in the summer of '99, last year at university.
Could you get closer to your microphone?
All right. I initially started in the summer of '99.
A little closer.
Can you hear me now?
That's perfect.
Okay, I'll just yell a little bit. Okay. I originally started in the summer of '99 as a summer student. And actually, it wasn't even Kevin at the time that hired me. It was the plant manager. He hired me to do what they called scab work in the plant. And that was basically write all the procedures for all of the operations that were happening in the plant, which made me very popular in the plant. They called me a scab because they figured we were going to outsource all of their work, but that wasn't the reason. So anyway, that summer came and went, and I was finishing up school, and Kevin contacted me, and he wanted to develop a new boiler. Actually, it started with a new controller, the Century controller.
Oh.
So that's where I got my start, was debugging the Century controller, which I did part of that, and then the field did the rest of it for me. So that was starting in 2000, and we between working on the Century, that kind of led into developing a condensing boiler. So started with the Matrix concept and went to the Trinity, which I'm sure a lot of the people on the line are familiar with the first Trinities.
Yeah.
So yeah, it's been 23 years-ish.
What was that?
It's been about 23 years for me.
Wow. Wow. What's your degree in?
It's in mechanical engineering.
Nice. So there's a rumor going around that your son Chris Thompson over in accounting is really your son. Could you clarify that for us?
He is most certainly not my son. I'm not that old. And he's not quite that young either. So. Great guy, not my son.
I had to throw that out there. I get asked that question all the time. So
he's not as young as he looks, and Jason's not as old as he would have to be.
Well said. So, I've been to the factory and done the factory tour and done the introductions for a lot of years. And Kevin Dennison likes to make this statement that Jason Thompson has to be the number 3 person in the world when it comes to combustion. So how is it that you're so smart when it comes to combustion, and are you number 3? And this is time for you to be either humble or bragging. You could do whatever you want.
Well, I'd like to know who's number 1 and 2. I don't know. I think combustion in this industry, and maybe many industries, is trial and error and experience. I've had the opportunity to speak to some pretty wise people in this industry, and our suppliers that produce burners. And the longer I'm in the industry, the more I realize that it is just that. It's experience and trial and error. If something doesn't work, you have to try something different. It's really that straightforward. Now, we generally have an idea what does work and what doesn't, and we know what to look for. So we're having pretty good success. But me being third in the industry, I think, is a huge overstatement by far. But That sounds like a nice story that Kevin would tell to his guests.
Well, you know, Gavin says if you say it 3 times, it becomes the reality, right?
That's right. Yeah.
So,
3 times and click your heels.
Yeah.
Yeah. So when it comes to combustion, and I look at some things, we'll get further into this, but you know, we have 3 distinct boilers that we can't convert to propane, and that would be the LX 600, 700, and 800. Why is that? Because we've had that boiler for about 18 years now, or 17 years, right?
Yeah, it's been, I'd say 14 years, 13, 14 years. Yeah. So the reason why we don't allow them to be converted to propane is just that, is the burner and the heat exchanger combination is really just not up to our standards on propane. And propane's usually the difficult one to tame. It always is, every time. So when we started development now, and for the past 10 years at least, we start on propane. We didn't when we were developing the LX through 800. We started with natural gas. We had a good solution. When we transitioned to propane in the development, we were far enough along that we took the decision we wouldn't do propane because it wasn't good enough. What it would take is a different burner and a modification to the heat exchanger. So it's often not just the burner. Usually the burner has to make up for shortcomings of a heat exchanger. So there are elements of that heat exchanger that make it troublesome with propane, where some other heat exchangers, that's not the case.
What do you mean by troublesome?
Well, you hit natural frequencies and harmonics with certain heat exchanger constructions. And there's subtle different things that heat exchanger manufacturer can do to kind of band-aid those. But that requires a different heat exchanger in our case. So oftentimes the burner can be calibrated to overcome them. Sometimes it just becomes too difficult. To find the sweet spot is too narrow, and it just can't go to the field.
Wow. That's because it's always just amazed me and everybody, and you know as well as I do, there's at least one time a year where somebody puts in an LX 600 or 700, 800 and says the propane kit's not here, and we have it marked everywhere you can't use propane on it. And I actually solved that one time with an LX 800 that was installed in a hangar, and encouraged them to find compressed natural gas, or what we refer to as CNG, or replace it with 2 LX 400s, and they went and found the CNG. So
yeah, we had one locally actually converted to propane. As a local contractor convinced a property owner to convert from natural gas to propane because he was offering very attractive rates, and he had an LX 800. He ran it that way for years. It didn't work really well, honestly. We eventually got contacted by the natural gas provider who was in there converting him back, and realized that it was an appliance that had never intended to work on propane. So they involved the safety authority and everything, and we got involved, and we had to recommission the boiler for them after converting it back to natural gas. So that was a fun time.
wow, how long had that boiler been in?
It's probably been in for maybe 10 years now. At the time, it had run a few years on natural gas and then a few more years on propane, and now it's been a few more years on natural gas.
So how did he run it on propane? I mean, it's an orifice. What got changed? What did he do to run it on propane?
What he did was he simply calibrated the gas valve. So it uses the same gas valve as a small FTG, for example. When we convert those, it's just a matter of dialing in the throttle screw, so you reduce the gas flow. So you're setting combustion. So he had done the same thing. He did it well enough that it managed to survive, but a lot of the ignitions could be rather pulsing, and it really taxes a lot of the seams in the combustion chamber when you do that, but it managed to hold up.
Wow. Wow. So whose idea was the 10,000 volt, the high ignition system? Was that yours, Kevin's, or you found that somewhere under a rock? How'd you come up with the 10,000 volt ignition?
Well, I can't remember who sourced the actual. Actually, it was Honeywell. Honeywell did it for us. A funny story: when we were developing the first LX, which used the Honeywell Sola, so it was our first experience with the Honeywell Sola, which was it was quite an interesting development. It was supposed to be a turnkey solution, and we spent a year and a half reworking it with them. In a way, it was a great experience because there were some great people at Honeywell at the time that we worked with hand in hand. But they touted that it could, it was hot surface. It was spark ignition, of course, but it had the integrated spark, the integrated spark transformer. So we were trying to ignite. It wasn't the first time we were using it. We were trying to ignite what would be an LX. So basically, it was a TI 150 or TI 200 that was going to become an LX 150 or 200, and it just would not light. We could not get it to light. So we happened to have an old Wild McLean Ultra. Well, old, it was probably a couple years old at the time. We drug it over, used the ignition transformer off of that controller, had it pretend like it was firing, and we used it to jumpstart our boiler. It was the most embarrassing thing ever. And that boiler also used a Honeywell controller. It was a different one. And, we were beside ourselves with Honeywell. Like, come on, guys. You're something that's this new controller. It's supposed to be better. It doesn't have as much oomph as this old controller. So they tried this. They tried all these different things to improve the power. And we just like, no. Because we came from the hot surface igniter era. And as long as the hot surface igniter didn't break, it was really good at igniting. So we got used to that. So eventually Honeywell presented to us at their cost. In fact, I think they gave it to us for free for the first couple of years. The ignition transformers, the Honeywell ignition transformer. And I mean, that did the job. And did it ever do the job? My God. We eventually transitioned away from Honeywell to Carlin, which we're still using on the TFT and in fact the new TFT we're using. So yeah, that's how it started.
That's amazing. I know. I just figured we had done it because we were an oil company, But that's a funny story to get us in kind of the back way into something great.
Yeah.
That's amazing.
Kind of reminded me of a time when we were working. Greg Hansen and I were working with Honeywell over the phone. We're on a conference call in I don't know if you remember the old training center in Sussex.
No, I never saw
it. You missed out. It's a separate building from the main plant.
Not that old house out in the front.
Yes.
Oh
yeah.
shit.
It had been many things in its life, a cement plant, everything. So anyway, we were on a conference call and Greg was describing some behavior that we were experiencing. And he just stopped talking. And this groundhog walked across the floor, right across in front of our feet, in the hallway, up the stairs. And Greg, and if you know Greg, he said, well, pardon me, but a gopher just walks in front of us. So that was quite a laugh for the Honeywell guys. So luckily, we're not in that building anymore, but it was quite interesting. It was, we certainly got a lot of miles on equipment just keeping that building from freezing.
Yeah, it's Mac actually took me out to Sussex and took me through that building, and I could imagine. I mean, it was horrible when I was there, and it doesn't sound like it was much better when you were there.
No. Well, one of my first jobs, actually, me and the guy I went to school with, after we first started, our job was to get the hydronic heat going in the building again. It hadn't been going for years. It was the office building originally and had been abandoned. So we would get a boiler hooked up, turn the water on, leaks everywhere. So we'd run around, soldering, putting pipes together, turn it back on again, be a leak over here, and fix that. And we spent a week or two. And finally, we just gave up and put fan coils in put new hex piping to the fan coils and blew heat through that way. But that's how we learned to solder.
I'm sorry, I could just imagine. I mean, here we are, in the top 4 boiler manufacturers in North America, and back in 2020, you're running around trying to put tape on pipes and make a building get heat. Jesus, unbelievable. So, I've been with the company basically since 2009 as a rep first, and then as a direct employee. Ted and I started as direct employees together in 2011. But I mean, we've seen, I came in at the tail end. The T had been gone out. The TI came in. The LX had just come in. The TFT was being coming out very soon. Right after that, of course, then we saw the TX, the TRX, the FTVN. In between there, we saw the Matrix go to the GF200, and then the GF150s coming out. We see all these changes, and there's some new stuff coming, but it's all, and everyone just keeps on getting better. But how the hell do you come up with the ideas? And I'm assuming they come off of your desk because you are the brains behind the operation. How the hell do you come up with these ideas to do this shit?
Yeah, I mean, it's, the ideas I don't think originate with me. I mean, I'm certainly very much involved in what we end up doing. Sometimes I'm curious of what we would have ended up doing if I weren't here. Perhaps we'd be much better off. I don't know, but I certainly can't take credit for being the entrepreneur. I mean, Kevin for years was the entrepreneur and had the ideas. I can't take any of that credit away from him. In the last 5 or 6 years, there's been a kind of a natural evolution based on our, being part of a bigger group, which we anticipated, we saw coming, and we welcomed it. And that's going to help guide our way. But one of the things I have found ever since we've been acquired is that we and you guys are a big part of this too. We are still driving. North America is still driving what it is we do. So, and we keep hearing that from the top too. And that's why we're all part of this group, is to take the decision as to what it is we do. So certainly I can't take any of the credit. I think the credit belongs to the whole group of us here.
So let me clarify. You say that the new boilers coming out are being driven by North America. Does that mean we're driving Europe for a change?
That's right. We're driving what Europe does here.
Speaking what does here, good question. Coming from Bill Mackey.
Interesting time where Europe's doing this thing that maybe isn't even the right thing, with the hydrogen and the different legislation. North America is always behind and goes a little bit, goes in a little bit different direction. So we're reaching this kind of strange turning point, and I think North America being slower could be a big advantage, in our industry being a little bit behind, because this is a weird time that's coming up.
So Ted, you had a question, you said?
Yeah, well, a question from one of our viewers, from Bill Mackey, who's an engineer who attends this regularly. I was wondering if we have plans to compete with the heat pump love affair, as he phrases it. Do we have any plans to go in that direction?
Yeah, I mean, certainly at the group level, it's happening. It's already happening for sure. Ariston is a leader in the heat pump hydronic heating world for sure. In North America, we don't have a presence, but it is certainly something very much on our radar, and we expect to be a player in that field for sure in the coming years.
Sweet.
That's good news.
So, Jason, looking back now on a 22, if I capture this right, 22, almost 23 years if you go back to when you were scab, career, what do you look at over the last 22 years as being your largest success so far?
I don't know. That's a good question. I don't know that I've had it yet. I'm waiting for the largest success. It's about to come out.
I like that. And if you could go back and change one thing, one thing that you've done, and what would it be?
Huh, gee, just one thing?
Whatever, however many you want.
Oh, I don't know. I mean, honestly, there's so many little things I would change, but I think overall, I like the way that things ended up and the path we took to get here. I don't think I would change anything in that regard. Certainly, there's been loads of mistakes, and we could have done things different to advance ourselves. You know, for instance, we would have started certain things sooner. We actually would have went with Honeywell solar before we did. We would have went with the Sept heat exchanger before we did. So there's, you know, the things that we kind of drug our feet or learned the hard way would have been nice to take the shortcut, but you know, until you don't know until you know. I think that's where we have a bit of a leg up now, where we do have so much depth that we didn't have in the past. It's harder to make those mistakes. Granted, things move a lot faster, so there's those mistakes still have a chance to happen, but you have a lot more oversight now than you used to. So, many small mistakes, but overall, I think it's worked out well. I wouldn't change it.
Well, and I've worked with or sold through my 24 years in wholesale and almost every other brand out there. And when I came to this company, just after the LX was developed and the TFT was coming, and I was fearful of joining a boiler company about what my world was about to become with the crap show I saw with everybody else. And I joined this company and in January, just like Ted, and here I am in the middle of winter, and I felt like a Maytag repairman. I mean, it was like no calls. I'm like,
Well, there's always calls.
well, yeah, but none of them were catastrophic. So somebody asked here on the screen, like they always ask me and Ted, what do you heat your home with?
I saw a wood question come up there. I heat my home primarily with the wood boiler, one of our wood boilers, mainly because I'm so cheap, and there's an abundance of forest around where I live. But actually, yeah, I use a wood boiler. I have a matrix in our home as well, so I get to test both forced air and hydronic heat and take the advantages of either. So my system, I really need to, I don't know, get Dave Nicholson or someone who's younger than me over to my place to teach them everything. So when I die, that they'll be able to figure out how to run everything, because it's pretty nasty, honestly, but it's fantastic. But yeah, wood primarily, propane through a matrix. So most part of my house is in Florida.
It should be noted that neither one of those products are available here in the States.
No, it is time for an upgrade. So part of my application is forced air heating through our products through wet heat. So like a GF could make sense for me. We have little, not little, but projects on the, within the group that we'll be involved in that could be coming up that involve heat pumps, hydronic heat pumps. So I'm holding out a little bit, but I would love to have an upgrade here pretty soon. So I'm looking forward to the next phase. But, but I will keep the wood. I will keep the wood, honestly.
So I'm amazed that you have one of those steel 36% efficient, burn a shitload of wood and create a lot of ash wood boilers that, of course, I was introduced to at New Yorker of Colmar. and you're making the exact same. We were making the same thing. Now that I'm with the company up in Canada, I can't believe you're using one of those.
Yeah, 1980 technology. Well, in fact, it was probably had one of the lowest efficiencies in 1980. But it works. You got to keep the fire hot, always burning hot.
Have you thought of going gasification?
No.
Again, it refers back to why you use wood heat. So, wow. So a lot of people don't. You've referred to the matrix quite a few times as what you started the company with and ended up with boilers. But I don't think Kevin mentioned it back when we interviewed him a year ago. But tell us why you. I mean, was the matrix really what drove us into the boiler business? A hot air combi boiler?
Yeah, I mean, of course, well, I say of course, but we were in the boiler business, for decades before, but not in the gas boiler business so much. We did have a gas boiler back in the 90s. But the matrix was our foray into the condensing boiler world, which was kind of didn't exist in North America yet, that market. So it's not like, hey, we should invent a condensing wall mount boiler, because it really just didn't exist here. But there was a project that was put on by the Canadian government where there was funding set up for a whole home heating system, and it kind of circled around space heating that was done by forced air heating. It included a heat recovery ventilator, which is mandatory in Canada, and it's not that mandatory in most of the states, but it is mandatory in Canada. And of course, your hot water heaters. That's what the matrix was. It brought together all these things. We attempted to get some funding, which we did, and we ended up ultimately producing the only appliance as part of that original venture that actually went on the market. It wasn't on the market terribly long, and we didn't sell a great deal of them, and it was huge and to some extent problematic. But anyway, out of that whole development, while we're developing it, we thought, geez, this one part of it would be great as a boiler. Why don't we just sell this as a boiler? So before it even got off the ground, we ended up kind of going sideways in developing the boiler.
Wow. So really we
back and did a matrix.
Amazing. Have you I mean, you go through a lot of, I'm sure you go through a lot of designs. I'm sure you go through a lot of prototypes. Ted and I have both been up there and looked at what we have in and around. I remember the first year I went up, we had just moved into a new building, the Denison building, and the second floor did not have manufacturing. In the corner, we had the little Jason blow up room, I like to call it, where you tested all sorts of stuff. But have you ever designed a prototype boiler and been to that point to where you've prototyped it, you've started up, you've run it, and then you, after all this investment, you've just scrapped it and said it's useless?
Well, yeah. I mean, that's really where we started with the first matrix. We were doing field tests. It was a heat exchanger that we made from scratch that was not very good, honestly. And we were in the field test, and it just in the end we decided this doesn't make sense. It's not good enough. We saw the up and coming Sept, Ginoni at the time, with their heat exchanger, and we completely scrapped it. That's certainly the most profound for me, was that. From that, our takeaway was, and this is something that Kevin's always said, is a matter of partnering with those who can do these certain components. It wasn't us at the time, and really hasn't been since. The expertise of building a heat exchanger for condensing boiler really resides with a very few, and they're generally just making their condensing exchanger.
So I just want to go back here. You said something in that entire answer that shocked me quite a bit, and you said we tried to design our own condensing boiler heat exchanger?
Oh yeah, we were building out of AL29-4C. We were taking the high road, like the best material possible for condensing heat exchangers. For the most part, we were siliconing and bolting stuff together, for the prototype stage. But we did put together some pieces for field test, probably half a dozen or so, that, well, probably none of them are still in people's homes, but they were in people's homes for many years. But yeah, it really wasn't working. It was interesting and was fun. I was brand new out of school myself. But in the end, it just didn't make sense for us to carry on. It really didn't.
So was it like a shell in a shell? Was it tube and shell? Was it multiple pass? Was it a coil? Was it a fire tube kind of?
They were water tube products. At least the one that we had got to as far as to field tested, a water tube product with a primary heat exchanger, a fin tube primary heat exchanger, and it passed through a secondary AL29-4C coil type heat exchanger with different types of baffles. So it was pretty convoluted for sure. It's actually kind of embarrassing to think about it now. Think of where we've gone.
Did you save that heat exchanger?
Now, honestly, for years, the brochure, and actually we made some wall mount boilers as well with this heat exchanger. But for years, the brochure for the Trinity, the T series, and even I think the TI at the very beginning, the brochure was a picture of one of the first prototypes. It was one that went in Kevin's house. It looked nothing like the real product. It was wider, bigger, but that was it. And that was what on the brochure. It was the best picture we had, so we went with it. In no way represented what we were selling.
I'm sorry, this is funny shit. So now we're working.
I have to say real quick though, at the time, and I was not familiar that much with NTI at that time, but the reputation was that those brochures were very hard to come by.
Yes, that's right.
Yes, we still try to put them together, print them ourselves, and fold them in half and stick them in an envelope.
Yeah, that's right.
I do remember we shared a rep at the time. I was with a different Canadian company, but he and his customers were always complaining that they couldn't get the brochure.
Yes.
I love it. So Ted and I have had a glimpse into the future of NTI. We've looked at some of the stuff, and we haven't shown anybody the stuff here. I may have featured on the original invitation when you logged in to go to webinar, maybe a front picture of a TFTN with a beautiful new touchscreen, but it's all sealed up so you can't see what the hell it is. You have no idea what you're looking at. People would assume it's a TFT with the screen in the wrong place, much like a 285 with the wrong brackets. Oh, did I say that? I'm sorry. So, what does the future hold over the next 5 years, would you say, or 10 years, or anything? What do you feel the future is? Where are we going? What do you see coming?
Well, I think for the next 5 years, it's still going to mostly be, the condensing boiler for us, and I think the market in general, the hydronic market. So our product line will evolve, continue to renew. So we'll complete within 5 years. We'll complete this renewal that we've been kind of working on, the TX to the TRX, the FTV to the FTVN, now the TFTN to TFT to TFTN. And I apologize for all the acronyms. It's terrible. I wish we had names. But so that's going to carry on. The renewals are going to carry on. It's where the bread and butter is. It's where the market still is and will be for a little while for sure. The beyond that is a good question. It really is a good question. We're kind of at this pinnacle where we could go different ways. I think the reality is, though, that a big part of our market is retrofit. They need heat. They need a significant amount of energy to heat these buildings. And a lot of the newer type of solutions probably really aren't there for this North American market. There'll be a niche. They'll become to be a niche. They'll become to be mandated in certain areas. But I think it's going to take a bit of a slowdown, especially for our key markets. And that's going to keep things kind of rolling the way they are. Doesn't mean that we aren't moving in those directions, because it's happening with our parent company out of Europe. And we'll be piloting some of those new products. Heat pumps, certainly it seems like it's going to be one of the drivers for us is the heat pump. Just what type of, how is that going to look? Is it going to be a packaged heat pump by itself, or packaged with a boiler, or two separate components going together? And these are some of the things that it's an interesting time for sure.
So I was always a big proponent of wood pellets. I thought wood pellets would be a great way to go with the new technologies and what's out there. And then I started looking to hydrogen, because the wood pellet just wasn't taking off, and people wouldn't get pumping tanks to deliver that. And so I started looking into hydrogen and started finding out the cost of making hydrogen. Everybody thinks that, it's free from water. It's H2, it's H2O. You just have to get the O out of the H2, and you got all this free hydrogen. And Honda, this stems from Honda probably 4 years ago coming out with an in-house hydrogen plant to fuel their hydrogen cars. And I come to find out the amount of energy it takes to create hydrogen and the cost of the equipment to make it is extremely expensive. Have we found anything better, or something that's could do it more reasonable?
I don't think so. I mean, what's driving everything, and I'm not going to preach what's a good idea, what's a bad idea, because I probably don't know. As technologies change, it changes everything. But what drives all of these things are the legislators, regulations, and with the case of hydrogen, really the regulation's not there. There's not a standard. Like, the products don't have a standard to follow to meet, and then the distribution. And so there's so much missing. We're so far away to get to where it actually starts playing a role here. I'm not saying it's not going to start and it's not going to move that way. It could eventually evolve, but I think there could be a realization in the meantime where, this doesn't make as much sense as we thought. To your point. So that's where I think in North America we'll have a little bit of an advantage, where we're a bit behind. Where in Europe they've been busy working on the legislation and changing the rules, and so the manufacturers have just had to produce the stuff, whether it made sense or not, or it didn't make sense. So I hope things evolve properly here to match what is logical. I think they have that opportunity to do it.
Ted, you had a question?
Well, I was going to say, to both your points, to Jason's point about legislation and to your point about the cost of it, we use ethanol now, and by all accounts, it takes more energy to create the ethanol than it returns to us in every gallon that it gets put into. So there's the magic of legislation and the disregard for the amount of energy it takes to create it.
Yeah. Are you saying the government is financing the corn industry, Ted?
That's pretty much exactly what I'm saying.
So, they want to go 100% electric, and then you start looking at the amount of electric it is needed to create hydrogen from water, and the electric company's just going, yeah, go for it. Let's sell the shit out of it.
Maybe, but then they're saying, oh my God, we got to invest trillions of dollars in our infrastructure, and we can't do it. So,
but if the government mandates it, the government will back up changing the infrastructure.
So in California, they mandate that they're going to go to electric cars, and then the very next day, they're telling people they're going to cut the electric. Go figure.
Yeah, it's an interesting time. So if they on top of make all the cars electric, make all the heating equipment electric, we're long ways away from being ready for that. We'll be retired before But it's going to be a fun journey, I think, at the same time. As we move there, it keeps the technology changing, evolving, so it'll keep us sharp.
So someone just asked, did anybody look into making voltage from the light off the flame to help create the hydrogen?
Well, maybe.
So, you'd make the hydrogen that would make the flame that would go into the water as heat, but also create the electric to create the hydrogen.
It's a perpetual engine.
Perpetual
motion machine.
Maybe.
Yeah, I just thought that was good. So when it comes to, you had mentioned heat pumps and future is very possibly heat pumps of some sort, air to air, air to water. So are we going to, we're not an HVAC company at this point, but are we going to team up with an HVAC company for the next generation boiler?
Well, at a group level, we are an HVAC company to a degree. I mean, the heart of what we do will involve, hydronic heating. Like that's our business. That's what we're looking to serve. That'll be our strength. And even at a group level, that's what it is. So, but at the same time, there's the component of cooling. And when you get into the world of heat pumps and you're cooling, we don't really want to be cooling the floor or cooling the radiators. We want to be blowing air and distributing coolness that way. So it'll be a hybrid system that's going to be successful. I don't think a fully hydronic system that doesn't incorporate forced air cooling is going to be, that's the only thing that's going to be successful.
I have a question. So as buildings get tighter and tighter, at what point does a radiant floor not make sense anymore because there's really no detectable warmth? And did we make a mistake by not promoting radiant ceilings, which in turn could be cooled?
Yeah, there's certainly a point. Certainly a point.
Loads get smaller and smaller. Radiant ceiling makes more sense because then you can only do you only need to do small sections of it.
It's certainly, and it's possible to do radiant cooling. You got to be really careful though. And you're right, it doesn't make any sense on the floor.
What, skating rink? I didn't hear you. A skating rink when it's humid out, slip and fall, lawyers every morning at 6 a.m. I didn't catch that.
The ceiling works though, because I did participate in a building in which we installed it and ran it. So the radiant cooled ceiling was actually quite effective, even in the eastern, part of the country where it's very humid.
Yeah.
Mm-hmm. Yeah.
So, one, thank you for spending the last almost 50 minutes with us and letting me ask you any question that I thought of, which some of them were fun and your answers being extremely truthful. Was there any question or any answer you have to any question I did not ask you?
No, I think we're good. I think this is really interesting. I haven't been paying attention to the questions, but be curious to. I hope that we addressed any of the questions that came up. I don't know. Do we have 2 people that are listening?
Yeah. So Ted's actually been asking the pertinent questions that were there. So what we do as a team, of course, is while you're talking, and if you see me look to the right, I'm not checking the level of my beer. I'm looking at the questions on my other screen, and I apologize for that. But this has been a fun night. I'm still questioning where you're going with what you want to put in your house. I'd like to know what you're talking to Dave Nicholson about putting into his framework that he's put up, because he's starting from fresh. So what's he going to do? I mean, he's got all the wood too. Is he going wood boiler also?
No. He's honestly, it's been a while since I spoke to him about it. I believe he's doing in-floor heating, but I noticed he's taking tomorrow off to do some work on his house. So I should circle back to him because I don't want to see him make a mistake and put staple up in or something like that.
Well,
God.
having said that, that heat pump technology, because of the type of temperatures it can very effectively provide, would be much more effective with radiant floors than it would with other types of hydronics.
Yeah, absolutely.
Especially port floors, because we get away with some really low temperatures with the new style flooring that we can put on top of it. And Ted and I were many years being involved with the RPA, and we spent years about floor coverings and installation styles. But so questions just came in, which I think is pretty funny because, you know, we had a vote off. You weren't around and for this, you know, unless you've been following us. And we had a contest for like new topics for this night, because I mean, this is our 51st night. We haven't duplicated anything. We've always been fresh and something new. Yeah, you're fresh and new, and believe it or not, and so we had this whole runoff, right? So I did it like a bracket, like, you know, like you do anything, right? Everybody played against everybody else, and we came all the way down. And the one that won was the fine print in installation operation manuals, which was probably the most boring night that I put together, that I had to have some sort of energy to make it fun, that people wouldn't say, screw you, turn me off, do whatever. So Bill McKay, Mackey, I'm sorry, who I love, says, when writing directions in installation and operation manuals, what's the most stupid point that had to be added to the manuals?
Oh boy. I don't know. That's a good question. And this isn't funny or anything, but you know, with each of the warnings, there's cautions with an exclamation mark, warning with an exclamation mark, a danger. So, you know, by law or by rule of the certifier, there's certain criteria we have to meet when we write something next to a warning or a danger. And just in general, like every time you think, oh, I got to warn them about that, you look at the rule. Like sometimes you look at the rules for what, and it's will cause death. It will. Like if you don't do it, it will cause death. And sometimes it seems so silly writing it. It's like it will cause death. Like, geez, if this happened and that and that and that. So just in general, it just sometimes seems pretty silly. But at the same time, there's some pretty silly customers.
I could go back in my notes and find that you wrote in those manuals 26 times, warning, this will cause injury or death. And you wrote 9 times, this will cause death.
I can't do both. Change it up.
Certain things might only injure you, and other things will absolutely cause you to die.
Yeah, no question. Nothing in between. Just death.
So Anthony Tassi, and I'm going to ask this question because, and I know the answer, but I want to ask you. In Canada, in your area, the typical 2,000 to 2,500 square foot house, what's the average BTU load?
Oh, it's probably 50,000 BTUs.
So not much different.
Not much different. It really isn't. We just don't open windows, and we put more insulation in. I think the products are size bigger than that, but like they are everywhere in North America, most places. But in reality, like my matrix, when I'm running on just hydronic heating, it's running at minimum firing rate the whole time. It only runs at minimum firing, and I get 2,500 square feet or so.
So yeah, the minimum that would fire at is 50,000 BTU, well, 30,000 BTU, right? It was the one TI 150 in there, so that would be.
That's right. So it's down to 25,000. So it's usually at minimum. Now, if I've had it off for a while, sometimes I'll let it go cold, and it'll, probably it is up to 60,000 BTUs for a while.
Wow.
Function of building code, and I think the Canadians have been ahead of us in terms of building code for quite some time. That's why nobody, when the matrix, and I, honestly to this day, I can't tell you how many people in this business that I talk to and they don't know what an air-to-air heat exchanger even is. You know, and that the matrix had it incorporated in 2005. You know, so that's the difference.
Yeah. So what are you doing for ventilation in your house, Ted?
I have an air-to-air heat exchanger.
Okay. What's typical?
Yeah, that's atypical.
Oh, I'm sorry. You want to know what I have for air heat exchange? It's called Windows. I got to my house here where I am. I walked in here. I walked in here yesterday and immediately walked around the entire house and opened up all the windows because they've been shut up for so long that it smelled like an 1800s house. And opened up all the windows. And I woke up this morning. It was 52 degrees out, and I was freezing. And then I went around and closed all the windows. You know.
Honestly, I do the same thing, except for when it's cold, or except when it's really cold. Cold for me. 52 is actually that's lovely weather for me.
Oh, I think it's lovely, but so what else? Any other questions coming, Ted, that we need to ask?
So let me see. Air to water, but look, it's more of a statement. It says, so air to water could be a solution. I'm assuming that was to the heat pump discussion we were having about heat pump and low temperature distribution.
That's right. Yeah, and that's an avenue that well, again, as a group, we're there already, not for North America, but that's going to be a step that you'll see us take in coming years.
So far, Jason, I've seen and read the information on 3 different air to water heat pumps that are available today in the United States. Not only are they low on BTU, but they state that when it's 20 degrees Fahrenheit, so you can convert that to Celsius in your world, they can't produce more than 120 degree Fahrenheit water. So that means that if someone's running baseboard in this area, instead of 600 BTUs a linear foot at 180, they're going to be getting 120 BTUs, which is based on 120 degree water. How the hell is that going to work?
Yeah, and it just isn't, right? So our market,
baseboard.
Yeah, our market is retrofit, and it's a lot of it's baseboard, and that's not for heat pumps. So I don't look to see what we're doing changing dramatically. There'll be aspects of it that'll change fairly dramatically, but there'll be niches and parts of the market that really are the big hydronic markets. So we're going to continue doing what we're doing, all of us, I think.
Question that was posed to me recently, speaking of which, and I certainly was the least, maybe not the least qualified, but certainly very unqualified to even deal with it. There was talk about carbon dioxide being used as a refrigerant, which in turn would be able to produce higher temperatures. Do you know anything about that?
I didn't quite catch that, Ted.
Your microphone, Ted, is doing something weird.
Okay, well, I guess.
Probably don't know, but I'm interested.
Carbon dioxide as a refrigerant, which would in turn be able to produce higher temperature fluids or output.
Okay.
And I was just wondering if you knew anything about it.
No, I don't know anything about it, but that's interesting for sure. And that would be a safe fluid to use for sure as well.
Well, here's the problem with CO2 right now, gentlemen, that you all know, most of you and almost everybody I think who's listening knows that I'm involved in the brewing industry as well as the boiler industry. I seem to bake bread, bake dog biscuits, make beer, and sell boilers. So I haven't gotten out of the bees yet, right? So, but I can tell you that right now in the brewing industry, we're having an immense shortage of CO2 because most of that CO2 is reclaimed from the production of petroleum products, and we can't get CO2. So, we can't, and everybody then answers me and they go, well, we have this, the whole reason we're doing this is because we have all this CO2 problem and, we gotta get rid of the CO2, but we have no way to pull that CO2 out of the air and bring it down and put it in a tank. So, but we can capture it in a stack going off of a petroleum factory, right? But we can't capture all of it. So, Ted, I questioned the CO2, and the other thing I questioned is somebody said to me they were also thinking of propane. And I'm thinking, well, isn't that great? I could just see a guy out there cutting into a line with propane in the house, or a small leak in a coil. Imagine what a small leak in a coil. We've all seen these coils fail over the last, umpteen years. Imagine a leak in a coil and what it's going to do when that ignites. But going back to the CO2, is it feasible to do CO2?
I don't know.
I think that any problem presents an opportunity. The person that figures out how to capture it is going to be in a very good position.
Well, and it's funny you say that, Ted, because in the brewing industry, we actually have, for your people like Miller and Bud and Coors who produce a crap load of CO2, it actually pays them to put a CO2 reclaimer that literally takes the CO2 off the fermenters, puts it through a series of filters and pressurizes it, and then cools it, puts it back into a liquid and pumps it into a tank for use on the next batch, which is fascinating. And in the brewing world, we're actually working on ways to close down and pressurize fermentation to reclaim the CO2 back into the beer. So it's pretty fascinating how we're saving it. But that, Ted, you're not far off with people working from that. But where do you put the hose? Where's the intake? I mean, where's the Ventura on a gas boiler? I mean, do we have a giant Ventura up in the sky that sucks it down? I don't know.
I don't know the answer, but I'm probably not the guy that's going to discover the methodology.
It could be interesting, but I think I showed this to you in the past. What's this? Yeah, somebody just sent me a link and I can't click on it. Jake Thrain sent over something about the Guardian.com environmental microwave owner home boiler could help out. Some sort of a microwave boiler. Do you know anything about that, Jason? Using microwave to heat water?
I don't see why not. It's interesting.
So maybe we shouldn't be working on a heat pump boiler. Maybe we should be working on a microwave boiler.
Exactly.
And
you put the water in the microwave and it gets hot.
You can boil water in a minute. Of course, it's just a cup.
Yeah, I don't know how its efficiency would compare to an electric boiler.
That'd be interesting, wouldn't it? But it's supposed to be exponential. And I also go back to it's not fusion we should be using, it's fission. And the safest way to control atomic energy. And we haven't come up with anything like that. And they were talking about having fission activators in everybody's house, which we haven't done yet. But Anthony Tossi asks, what do you think about a major boiler accessories manufacturer entering the heat pump market?
Huh.
So here's a guy who doesn't make boilers who's getting the heat pumps.
One for big manufacturers for sure. Whether it's the air to water or air to air, it's a commodity. It's not so much a commodity the air to water. I mean here, but it is in the rest of the world, or a lot of the rest of the world, in Europe at least. So it's going to be a tricky one to actually enter into and take a purchase probably by somebody who's interested. But it's going to happen. It's going to happen, and it just how big it happens is going to depend on how the legislation moves. There's already incidents, of course.
Yeah, I just fear for the infrastructure and
yeah, of course,
that the rolling blackouts and
being enough as well.
Being what?
Being enough, temperature-wise, capacity-wise. Yeah, again, I think we're back to, we still need that supplemental heat, in your house by way of right now gas boiler.
So, or two 6,500 watt elements inside of a tank like they use in
Yeah,
Chicago.
yeah, right. Then we're back to the whole infrastructure debacle.
Yeah. So when it's cold, but anyway, so I've kept you 12 minutes after our agreed to time. Jason, you can answer questions as long as you want. I want to give you out because you are an hour ahead, and I do know you. You are up before the birds. You are catching the worm, and you're in that office long before anybody at most days. So I don't want to keep you too late.
Well,
But
the cleaning lady already left, so I better go lock up. All right, I appreciate the opportunity, guys, and I'll say goodbye to everyone on the call, and you guys know where to find me, I think.
Thanks for watching the video today. If you'd like to check out more videos, see the link below. Don't forget to like, share, and subscribe to our channel for all the future updates. And also check us out on Facebook, LinkedIn, and Instagram.